the places on Earth where humans can feel close to the heavens, none can beat the rocky desolation of Chile's Atacama Desert. Here, where rarely a cloud is seen, peak after towering mountain peak thrusts into the dry, still air. And each night, as darkness descends, the stars shine with an unblinking clarity that rivals the view from space itself. Once nothing more than a distant curiosity, this harsh and remote landscape has become the focal point for some of the most exciting developments in our exploration of the universe. And there is much more to come. Today's state-of-the-art telescopes are larger and more expensive than ever. So to get the most out of them, astronomers want to put those telescopes where they can be used to their best advantage. The Atacama offers just such a place. It's the driest desert on Earth with only a handful of cloudy nights each year. The airflow is remarkably steady, and it's far from cities and towns that throw light into the night sky. Put it all together, and you have a gateway to cosmic discovery. Today, Chile is home to some of the world's most impressive observatories. And here, high atop Cerro Paranal, is the most impressive of all. This is the VLT, short for Very Large Telescope. Despite its name, it's actually 4 large telescopes, plus 4 smaller ones, which can either work independently or together, like a giant light-collecting machine. Part of the secret to the VLT's success is its location. Perched more than 2.6 kilometers above sea level, Cerro Paranal boasts the ideal atmospheric conditions for astronomy. But there is more than an exceptional sky at work here. To produce views that challenge the Hubble Space Telescope for beauty and clarity, the VLT also relies on some exceptional technology. It starts with each of the 4 large telescopes' main mirrors. Each one is a single piece of aluminum-coated glass 8.2 meters across, but less than 20 centimeters thick. Such a large but thin mirror would naturally bend under its own weight. To prevent that from happening, the VLT employs a strategy for keeping its 4 giant mirrors in shape. Each rests on a bed of 150 pistons, called actuators, which can press on the mirror at different points. The actuators bend the mirror by just the right amount to maintain its ability to focus, no matter how the telescope is moved or tilted. Such precision is perfect for roaming the rich star fields of the southern Milky Way. Here, like a bubble frozen in time, the VLT spies the Dumbbell Nebula, a ballooning cloud of gas made up of the outer layers of a dying star. Nearly 20 times farther away, the VLT finds a burst of celestial fireworks in mid-eruption. The largest and brightest stars in this cluster would outshine our sun 8 million times over. These images are all the more breathtaking because they are taken from Earth, not from space, by an observatory that is swimming in air. Even on the clearest of nights, unseen turbulence in the air pushes starlight around as it journeys through Earth's atmosphere. The same effect is what makes the stars twinkle. To get around this problem at VLT, all the light gathered from each telescope's main mirror is bounced onto a second mirror, which can rapidly deform to reverse the distortions caused by the moving air. Like other observatories in Chile, the VLT is in a perfect position to put its cutting-edge technology to use. In the northern hemisphere, the central regions of our Milky Way galaxy can barely be seen above the horizon. But in the south, the galactic center arches high overhead. Shrouded behind dark ribbons of interstellar dust, the center of the Milky Way is an elusive target. But the telescopes of the VLT can also detect infrared light, which can pass through the dust. In this unprecedented image, the VLT has revealed the spectacular concentration of stars at the heart of our galaxy. Here, dozens of giant stars crowd a region that is only 2 light years across. Astronomers can now return to this view again and again to see the stars moving as they orbit the giant but unseen black hole lurking at the heart of the Milky Way. In every journey, there is always another mountain, another spectacular view. What we will find, we do not know. What we do know is that in the journey to explore the cosmos, our path leads through the Atacama. By night, the skies over Chile's Atacama Desert offer a dazzling spectacle. Some of the best views of our universe found anywhere in the world. By day, the stars fade away, and the giant telescopes on their mountain perches retreat into their domes, shunning the harsh southern sun. Yet, even in broad daylight, there is still plenty of universe to explore. Radio waves reaching the Earth from the depths of space carry information about distant events in our galaxy and far beyond. For years, radio astronomers have been scanning the skies with giant dishes and picking up the faint signals that come from sources all over the universe. But there's one frontier left to conquer. Astronomers call it the submillimeter. That just means radio waves that are very short, less than 1 millimeter across. It turns out some of the most interesting phenomena in the universe, from the births of stars to the most distant galaxies, are giving off energy at those wavelengths. But there's a problem. Water vapor in Earth's atmosphere is very good at blocking sub-millimeter waves. So, to see the universe at those wavelengths, astronomers need to go to one of the highest and driest places on Earth. And that place is here, 5 kilometers above sea level. Nestled among the high peaks of the Andes Mountains, astronomers are building the Atacama Large Millimeter Submillimeter Array, ALMA for short. When completed, it will be the largest and most sophisticated radio observatory on Earth. At its heart, ALMA consists of 66 large dish antennas, some built in Europe, some in North America, and some in Japan, reflecting the international partnership behind the project. Each dish is a nearly perfect parabola, precisely tuned to pick up signals at sub-millimeter wavelengths. Each dish on its own would be an impressive tool for exploring the heavens. But at ALMA, the dishes will work together as one, creating a giant, steerable receiver that will probe the skies with unprecedented sensitivity, gradually building up a view of the universe as we've never seen it before. One of ALMA's highest priorities will be exploring the complex tangle of interstellar gas and dust that spans the plane of our Milky Way galaxy. In doing so, it will not only witness the formation of stars, but in some cases, it will discern young planets emerging from the debris that surrounds those stars. Something that happened in our own solar system 4.5 billion years ago. To satisfy the variety of groundbreaking observations that astronomers hope to make with ALMA, the array needs to have more than just a large number of dishes. It must also be able to change the arrangement of its dishes depending on the kind of observation that is being made. For some targets, ALMA will work best if most of its antennas are clustered towards the center of the array. At other times, they will need to be much more spread out to increase the precision of the entire array. At its widest configuration, ALMA's antennas will be spread out over 14 kilometers. Moving these antennas around will not be easy. Each one is a high-precision scientific instrument that also happens to weigh about 100 tons. To do the job, ALMA has 2 special transporters, as massive and muscular as they are maneuverable. Transporters feature 28 independently controlled wheels and can move fast across the high desert roads. But in practice, when one of ALMA's antennas is being transported, the driver will aim for a gentler ride. The ability to adjust the locations of its antennas is just one way in which ALMA will optimize its view of the heavens and bring a new level of detail to our exploration of the distant universe. Because ALMA will be able to zero in on small and remote objects, it will be perfect for isolating and measuring the properties of very distant galaxies. Looking back to a time when the universe was less than 1/20th of its current age, and the very first galaxies were forming out of the residue of the Big Bang. By taking advantage of some of the most beautiful skies in the world, this incredible new observatory will help transport astronomers deep into the past. What they hope to find will answer some of our deepest questions about the origins of the universe. In one of the driest and most desolate pockets of Chile's Atacama Desert sits a maze of weathered rock formations, sand dunes, dry lake beds, and salt deposits that glint like snow in the desert sun. Here, more than anywhere, the otherworldly quality of Chile's extraordinary landscape seems at its most intense. This place is called Valle de la Luna, the Valley of the Moon. Tourists come to experience what it might feel like to set foot on another planet. In the 1990s, researchers came here to test an early prototype for a rover on Mars. The Atacama seems so much like it's part of another world. Perhaps it's fitting that now it's leading us to new worlds across the galaxy. At the VLT on Cerro Paranal, astronomers have zoomed in on Beta Pictoris, a nearby star easily visible to the naked eye in the southern hemisphere. For years, it's been known that a swirling disk of dusty debris surrounds Beta Pictoris. And more recent observations indicate that at the center of the disk, there's a gap, roughly the same size as the orbit of Saturn in our solar system. Astronomers suspected a large planet was responsible for the gap, because a planet's gravity would sweep that part of the disk clear of the dust and small chunks of debris that had coalesced around the newborn star. But finding such a planet is like looking for a very small needle in a very large haystack. In 2003, by using the VLT's infrared capability, astronomers were able to spot a faintly glowing dot located very near Beta Pictoris. It looked promising, so they waited. 6 years later, their suspicions were confirmed. By 2009, the object had moved to the other side of the star, clearly showing that it is a planet orbiting around Beta Pictoris. The planet is estimated to be 8 times more massive than Jupiter, not a place where we would expect life to emerge. But where one planet exists, there could be more. The Beta Pictoris system, located only 60 light-years from Earth, is just one more reason why astronomers are drawn to the southern hemisphere. By sheer chance, the night sky we see below the equator is particularly rich for stargazers. For those used to the more subdued skies of the north, a first glimpse at the southern Milky Way, with its vast star clouds and dark tendrils of interstellar dust, is simply awe-inspiring. Taking a cue from the scientists at the great observatories, more and more of backyard astronomers are now coming to Chile for a chance to glimpse what they cannot see in the north. Here, even a quick scan with binoculars can offer rewarding views of the region's signature constellation, the Southern Cross. Elsewhere, an ordinary digital camera can bring out the subtle colors in the glow of ionized gases where new stars are forming. Like their professional counterparts, the amateur astronomers who come to Chile have found that technology can help them get the most out of the view. For example, the movement of air will cause an image to blur slightly, no matter how good the seeing conditions. But by taking hundreds of images of the same object and then digitally combining them, it's possible to create images of astonishing clarity. Here, the method is used to bring out fine details in the Eta Carina Nebula, one of the great spectacles of the southern sky. Humans have been looking at the stars since before written history and exploring the universe with telescopes for centuries. But it may be that nowhere on Earth have humans found such a strong connection to the night sky as in the Atacama. It truly is a stargazer's paradise. Perhaps it requires being in a place that is far removed from earthly affairs to see the possibilities that lie beyond our own world. With each generation, we have seen farther and encountered wonders greater than we can imagine. From the barren rocks of the Atacama, the path now leads deep into the galaxy. We do not know if our descendants will ever venture to the stars, but should they step away from Earth's embrace, we can, from here, begin to see the way. In the Atacama, we stand poised at the cosmic doorway. What lies beyond is the road to cosmic infinity.